semuanya melibatkan given acceleration functions. Okay. Alright. So here in this sample problem, okay, the statement given is very short. Okay. So I'm not very sure whether this example is given given this data or not. But now let's we assume that this data is initially is not given. Okay, let's be assume that this data is initially not given. So now this is where you need to learn about how to illustrate, how to express, or how to give the data here into a diagram. Okay. All right. Now the statement given is ball tossed with 10 meter per second vertical velocity from window 20 meter above ground. Okay. So this statement, every single word is very helpful and very important. Okay, dia sebut pasal bola. Dia kata ada bola, toss. Bila kata toss, okay, pergerakan tu bagaimana? Toss tu maksudnya apa? You baling ke atas ataupun you baling ke bawah?
Ke atas.
Atas.
You baling ke atas. Maksudnya pergerakan partikel tu akan pergi upward. Right? Okay, so initially pergerakan bola ini dalam keadaan going upward. Alright. So dia kata the ball tossed with 10 meter per second vertical velocity. So dia tak kasih interval functions dia kasih interval value. So maksud inilah initial velocity. You have initial velocity for this ball is V naught equal to positive 10 meter per second. How do we know positive 10 meter per second? Okay, kalau you complete baca tadi statement tu, dia kata apa? Vertical velocity from window 20 meter above ground. So you need to define first. Okay, let's say this is your building. Okay, dia start balik dekat tingkat ni lah. Okay, tingkat ni berada dekat mana? Tingkap ni berada dekat 2 meter above ground. Ni you punya ground. 20 meter above ground. Dan pergerakan bola ini dalam keadaan upward. So meaning that our coordinate axis is also positive upward. So this is our coordinate axis, which is this is your origin, 0. Okay, you start measure the distance or the height of this ball start toss to from this ground, go upward. So you ada position dia y initial equal to positive 20 meter. Kenapa positive? Sebab dia berada above origin. Okay, ataupun above ground. Okay. And then, tadi kita kata pergerakan bola tu dia initially go upward sebab dia baling bola ke atas. So, V naught. Okay, V naught will be equal to positive 10 meter per second. Kenapa positive? Sebab dia follow the positive directions of the coordinate axis ni. Okay. And then, apa yang berlaku? So, bila kita baling bola, sebab dalam case kinematik, ni case kinematik kita tak consider any forces effects. Okay, bila kita baling bola, dia akan free to fall. Dia akan free to fall. Okay, dia akan free to fall. So, bila berlaku condition free to fall, bermaksud adanya acceleration yang mana equal to gravity. Adanya constant acceleration which the value is equal to the gravity value, yang mana gravity value adalah equal to 9.81 meter per second square. Disebabkan directionnya ke bawah, pergerakannya di bawah, so you akan ada negative sign here. Okay, so this is how you need to translate all the information into diagram. Okay, all the basic thing that you need, that you know, you have to express it into diagram. Okay, so once you have this, then you can start think about how to solve the problem. Okay, so now let's be look to the question. The first question asks you determine the velocity and elevation above ground at time t. The second one, highest elevation reached by ball and corresponding time, and time when ball will hit the ground and corresponding velocity. Okay, so sekarang ni the next thing before we can proceed to the solutions, you need to think first what kind of value or result that you need to have. Okay, For example, for the first question, determine velocity and elevation above ground at time t. Dalam bentuk macam mana jawapan yang you kena ada sebenarnya? Adakah dalam bentuk satu value ataupun bentuk function? Macam mana?
Function.
You should give in term of function. So kena letak lah. You akan dapat dalam bentuk v as a function of t and x as a function of t. This is the result that you need to get. Okay. So bila kata you nak v function and x function, then you dah boleh tahu dah, oh kalau dapatkan v function dengan x function, bermaksud you perlu ada apa? If you want to have v function and x function, okay, what you need to have in order to develop these two functions?
Acceleration with function of t.
You kena ada acceleration as a function of t. Okay, that's good. All right, you need to have a function first. Okay, so from this function, you will conduct twice integration to get vt and xt. Okay, integrate a, you will get v. Okay, integrate v, you will get x. Okay, the next one is determine the highest elevation reached by ball and corresponding time. Okay, dia nak apa ni? Macam mana simbol kita letak kat sini? Dia nak y apa? Y maximum. Berapa y maximum dia? And pada waktu bila y maximum ni berlaku? So apa yang you tahu bila kita sebut pasal y maximum ni? Apa additional information that you can provide here?
V kosong.
Kita tahu when y is maximum, when elevation maximum, your velocity is 0. Good. Okay. So we know that in this case, we can provide additional information where v is equal to 0. Okay. And then the last one, time when ball hit the ground and corresponding velocity. Dia nak time when ball will hit the ground and corresponding velocity. What is the additional information that you can highlight here? Dia kata apabila bola tu hit the ground. So berapa time dia and berapa velocity dia. Apa information yang kita boleh provide kat sini? Additional informations. Waktu bila dia berlaku ni? Dia berlaku apabila y is equal to 0. Nampak tak? Sebab dia dah hit on the ground. Bila dia hit on the ground, apakah position dia? Position dia adalah 0. Okay? So this is something that you have to think about first before we can proceed with the solutions. Okay. Once you have all this kind of plan, then we can dapatkan detailed solutions lah. Okay. So from here, okay, so from here we know that we are required to have a in order to get v functions, and then later on we can get x function. Okay, the question is, what is the a value that we have here? Tadi based on our illustrations tadi kita ada a sama dengan apa? We have constant a. In this case, dia masih ada sebutan t ataupun sebutan x ataupun sebutan v. dalam problem kita ni, kita tak diberi function A, tapi kita diberi constant A. Kita tak diberi, kita define, we have constant A equal to, here we have A is equal to 9.81 meter per second square. Okay, negative 9.1 meter per second square. Okay, where we know that in this case, since that we are talking about v with respect to time t, x with respect to time t, so we can relate a here is equal to dv over dt, where a is equal to negative 9.81 meter per second. Ingat bila kita diberi a, sekarang ni you kena tahu kita kena conduct integration. So before we can conduct the integration, you must go through with this process first. First, define what is the kinematic relationship that can be used to this problem. Okay, and then next, we rearrange it until we can do the integrations. Okay, so here we have equal to negative 9.81. So we bring dt to the right-hand side. Okay, so you're gonna do these functions lah. Okay, and then we introduce the integration sign. Okay, so before we can do the integration, we need to put the limit from v0 to vt, 0 to t. Then now you can integrate. So based on the integration process, we get this result. Okay, then kita kena again rearrange it until we can express v as a function of t. Kita nak v as a function of t, so meaning that we have to bring negative v0 to the right hand side. Yang mana dia akan jadi vt is equal to v0 minus 9.81 t. Okay, so we have v0, we are given v0 equal to 10 meter per second. Okay, and then still remain the same. So this is the function or the answer for the first one. Okay, for the first one. Okay, and then later dia nak dapatkan function x. Okay, to get the function x, again, we need to do the integration because now we only have a and v functions. Okay, so to get x function, we are required to have v function. So we already derived the v function here. Okay, now we need to call the related kinematic relationship to derive for xt, which is we have v is equal to dy over dt. Okay, and we based on the result here, we have v is equal to 10 minus 9.81. So this is the first step. Second step, okay, we rearrange it until we can do the integrations. Okay, put the limitations, then integrate. Then finally you got this result from the integration, and finally we rearrange it. Okay, we bring y0 to the right hand side, then you have this final result. Okay, so now this is how we derive for the v function and y functions. Okay, so based on these two functions, then you can solve for the second question. Second question asks you to find the highest elevation reach. Okay, disuruh cari highest elevation reach. So meaning that we have to look to these functions. Okay, we have to look to these functions. Okay, so from this function, you have t. Okay, but we don't have t. How can we get t? To get t, we can use v function. Okay, we can use v function. But how can we use this function? We know that based on the basic concept, y maximum occurs when v is equal to 0. So we make it this v function equal to 0, then you can get what is the t value. So the calculated t value here, then you go back to this function to get what is the maximum elevations. Okay, any question? Ada soalan? Any question for this one?
Tak ada
So
soalan.
far, no question, Doctor.
All right. Okay, next. The next question asks you about to find the velocity when the ball hit the ground. Mana gambar dia tadi, bila ball tu hit the ground. Berapa velocity dia. So basically sebenarnya kita fokus on this function. Okay, berapa velocity dia apabila dia hit the ground. Okay. But again, kita tak tahu time dia berapa. We do not know the time that we can use, that we can substitute into this function to get the velocity. So then we will get t value by using y function. Okay. So in order to use this y function, we equate equal to 0. Kenapa equal to 0? Sebab apabila ball hit the ground, the position is equal to 0. Okay. So now based on this quadratic function, it will give you two results, positive value and negative value and positive value. Since that we are talking about time, so there's no negative time. So we will choose t equal to 3.28 to be substituted into these functions. Okay, so finally you can get the velocity. Okay, negative 22.2 meter per second bermaksud velocity itu is going downward. Is it correct or not? Yes, but dia pergerakan dia ke bawah, daripada atas tadi dia go downward directions. Okay. Alright, so that's all for this sample problem. Any questions so far?
No, Doctor.
Okay, so now we move on to the next sample problem. Okay, tadi ini kita diberi A constant A. Now the next question is again, for this one actually it's not given. Okay, it's not given initially in the question. Okay. Alright, so that we read the question, read the statement first. Okay, kita ada mountain bike mechanism. Okay, ini adalah mountain bike mechanism. Okay. Dia kata apa? A mountain bike shock mechanism. Okay, you baca-baca dia kata bla bla bla. Shock absorption consists of this one that travel in a oil cylinder, oil filled cylinder. Dalam ni dia ada oil. Okay. And then as the cylinder is given an initial velocity, V naught. Okay, dia ada initial velocity tetapi dalam sebutan V naught. Okay. This mechanism moves and oil is forced through this in piston causing this element and cylinder to decelerate. Okay. Bila dia bergerak, this one, okay, a cylinder is given an initial velocity, the piston move and oil is forced through orifice in piston, causing this mechanism and the cylinder to decelerate at rate proportional to their velocity. Okay, nampak tak kat sini? As I said, initially dia tak kasih ni but then you have to translate it into mathematical form based on this statement. Yang mana dia causing decelerate at rate. A berlakunya decelerate maksudnya negative sign kena ada. Okay, negative velocity, negative acceleration. A decelerate proportional to their velocity. Dia tak boleh A equal to negative V. Dia mesti ada coefficient here. So basically you have this function of A. A is a function of V. Okay, you are given A is a function of V. Yang mana AU adalah dalam bentuk decelerations. That's why you ada negative sign. Okay, that's why you have this negative sign. Okay, so that is statement. So apa yang kita nak cari? Determine VT, XT and VX. Okay, determine VT, XT and VX. So we are given A. Okay, we are given A, then we need to get function V as a function of T, X a function of T, and V as a function of T. And again, we do understand that when we are given a function, we need to integrate. We need to integrate it to get velocity. Okay, tak kisahlah velocity as a function of T ke, velocity as a function of X ke, we need to integrate A to get these two functions. Okay, once you get these two functions, okay, then later on you can derive for the position functions. Okay, Alright, so this is the overall idea in order to solve for this problem. Okay, as we know, when we are talking about A as a function of velocity, we can relate with the kinematic relationship of V dV over dx. Okay, disebabkan kita punya A function dalam bentuk V, dan kita akan guna kinematic relationship of V dV over dx. Okay, so from here, then we can start derive for Vt, Xt and Vx. Okay. Alright, so now here we want to derive for V as a function of t and then later x as a function of t by given A as a function of V. So in order to get this, based on this, then you need to choose AV is equal to dV over dt. Okay, yang I cakap tadi ni, yang ini, apabila you nak cari V as a function of X. Okay, if you want to get V as a function of T, then you need to use AV equal to dV over dt. Okay, alright, so now we have this first step. A is equal to dV over dt, where A is equal to negative kV. Then we bring dt to the right hand side, so V down here. Okay, then you will have dV over V and negative K dt. Okay, then kita integrate derivative lah. So when we integrate 1 over V dV, it will give you what? When you integrate the 1 over V, dapat apa? Huh? Okay, V naught to V over V naught. Okay, alright, next. Ini V as a function of T, bukan V darab T. Okay, this is V as a function of T. Okay, so the result from the left hand side, you will get ln V as a function of T over V naught. The result that you get from here is equal to negative KT. Kita just integrate dt saja. K tu tak perlu integrate sebab dia dah constant value. Okay. Alright, so from here we have ln V over V naught equal to negative KT. So kita nak dapatkan function VT sahaja, kita kena hilangkan ln tu. Macam mana kita nak hilangkan ln? Ln kat kiri ni hilang dan kita kena introduce exponent on the right hand side. Okay, so you akan ada Vt over V naught equal to exponent negative KT. Okay. And again, since that we want to have V as a function of T only, so we bring V naught to the right hand side. So we have this one. So this is the function of V in terms of T when we are given A a function of V. Okay. And then the question asks you to get xt function, x at T. Okay, ni xt functions. Okay. Alright, so to produce this function, again, we need to choose the appropriate kinematic relationship, okay, which is we will use Vt is equal to dx over dt, where your Vt, based on the previous derivation, we had V naught exponent negative Kt, okay. And here we just look on these two parts, okay, then we will have dt bring to the right hand side. So yang tinggal hanyalah ini. Okay. So you have dx integration from 0 to x and then you have v naught. V naught ni kenapa kita tak integrate v naught? Sebabnya v naught ini bukannya functions. V naught ni diberi in term of constant value. Okay, in term of value. Bukan constant lah, dia ada value. Bukan constant bila constant pula, dia tak ada perubahan pula. Dia adalah value. Alright, so that's why kita tak perlu masuk dalam kita punya process of integrations tu. Yang perlu diintegrate hanyalah exponent. Okay, bila kita integrate exponent, then you get this. Okay. Right, so the final result that you get here is okay, you need to substitute t and 0 into here, then you will get the function of x in terms of t. Okay, right, so this is the detail ataupun example on the derivation for v as a function of t and x a function of t by given a functions of the v. Okay, all right, and then the last question asks you about to get the v as a function of x by given a as a function of v. So now to derive for this, the kinematic relationship that we need to apply here is v dv over dx. Okay, so as you can see here. All right, so we have v dv over dx equal to negative kv. Then we have to exchange these positions sebab kita kena kumpulkan mengikut parameters dia. Okay, so kita ada v dv over v equal to negative k dx. Okay, so ini kita boleh simplify kan. So kita ada dv equal to negative k dx. So as you can see here lah. Alright, then kita integrate. Okay, menggunakan given limitations. Okay, then we have this and then we rearrange it until we get the velocity. Ini v as a function of x. Nampak tak ada sebutan x dekat situ. Yang v naught ni again dia ada value. Okay, tapi dalam sebutan v naught. Alright, so this is how we derive the velocity function and position function sama ada dalam sebutan t ataupun sebutan positions. Okay, ada soalan? Ada soalan? No question? Okay, so these are alternative solutions. Okay, to get the v as a function of x, yang mana kita just work with between a and b. Okay. Alright, so for this one, you can check by your own. If you have any question, you can ask me. Right now, I would like to move on to the next one. Okay, ada soalan tak before I continue?
Tak ada soalan.
Okay, so now ini adalah group problem solving. Okay, normally I will ask you to study by your own, but never mind because you have no partner to study with, right? Now let me discuss. So here we have a bowling ball is dropped from boat so that it strike the surface of a lake with a speed of 8 meters per second. And then assuming the ball experiences a downward accelerations of A equal to 3 minus 0.1 v square when in the water. Determine the velocity of the ball when it strike the bottom of the lake. A and V expressed in meter per second square and meter per second respectively. Okay, now we already read the question one time, then you have to read again in order to you to translate or illustrate it into diagram. Okay, so kita apa? Okay, dia akan kasih gambar rajah ni lah. Okay, dia kasih gambar rajah. Okay, dia kata a bowling ball is dropped. Drop maksudnya you jatuhkan dia ke bawah lah. Pergerakan maksudnya pergerakan partikel ni bagaimana pergerakan dia ke bawah. So meaning that our coordinate axis will be assumed downward positive. So ini adalah origin. So everything going downward below this water adalah positive. Okay. Alright. So dia kata apa? Boat strike. So that is strike the surface of a lake with a speed of 8 meter per second. Dia kata speed. Ni adalah magnitude saja. You dah tahu dah directionnya apa? Directionnya apa? Ke bawah. Dengan V equal to 8 meter per second. Ini adalah V naught. Okay. And then assuming the ball experiences a downward acceleration. Downward acceleration A. Maksudnya A positif lah. A is equal to 3 minus 0.1 V square when in the water. Okay. Determine the velocity of the ball when it strike the bottom of the lake. Now we are given A is a function of V. Okay, kita ada A given as a function of V. Soalan dia, fahamkan, determine the velocity of the ball when it strike the bottom of the lake. Okay, so apa yang you akan dapat? You akan dapat dalam bentuk apa? Dalam bentuk position function. Sorry, you akan dapat bentuk velocity dalam sebutan positions. Sebab dia talking about when it strike the bottom of the lake, which is we can describe this condition in term of distance. So meaning that the velocity here should be expressed as a position parameters. Okay, so you punya function of velocity ni should be expressed in term of positions. Okay, alright, so now dia nak suruh you tunjuk which integral should you choose. Kenapa B? Kenapa bukan A? Now you tell me, kenapa bukan A? Apa kesilapan dekat A tu? Apa dia? Kesilapan dia? Naufal. Kenapa jawapan A tu salah? Naufal.
Mungkin sebab dia tak ada derivation.
Sebab dia tak ada derivations? Okay, now you tell me. Sekarang ni I ada A as a function of V. I nak derive for V as a function of X. Apa kinematic relationship yang I nak kena guna kat sini? Apa kinematic relationship yang I nak guna dekat sini? Ada berapa option? Hazim, ada berapa option yang I boleh pilih kat sini untuk A as a function of V? Ada berapa kinematic relationship yang I boleh pilih? Yang I boleh guna? Hazim? Apa dia? Dua tu?
dx over dt.
dx over dt? dx over dt? Muhammad Razi. Apa dua tu? Kalau kita sebut pasal A diberi dalam sebutan V, nak derive untuk velocity, kita boleh derive dengan menggunakan relationship yang mana satu? Tadi kawan you sebut dua. Okay, betul ada dua. Yang mana apa dia? Apa dia, Muhammad Razi? Sebab kelas ni pasif sangat ni. Apa dia? Muhammad Razi? Ada ke tak ada ni? Nakib Marikan.
Ya doktor,
Hmm.
kita boleh pakai dv over dt sama dengan ab.
Atau?
V
dv dx.
sama dengan ab.
V dv over dx.
dx
Okay. Bila kita diberi A as a function of V, okay, untuk derive for the velocity, kita boleh menggunakan kinematic relationship dv over dt ataupun v dv over dx. Okay. Alright. Apa yang I bagi tahu tadi? Kalau I guna AV is equal to dv over dt, apa je yang I boleh derive daripada sini? Alia? Alia? Alia Nabila, wujud tak ni? Tak ada? Alia Nabila tak ada? Iza Sofia?
Ya, madam. Kalau integrate dv over dt, aku dapat dt.
Tak dapat apa?
dt.
DT?
Sekejap. Kak main tanya kalau integrate dv over dt ke?
Kalau I ada AV. Okay, sebab AV ni you boleh derive untuk V as a function of T, you boleh derive X as a function of T, you boleh derive V as a function of X. Okay. Kalau I guna, sebab bila I nak derive ni, dia akan menggunakan different kinematic relationship. Untuk VT dengan XT akan guna satu kinematic, akan ada dua lah tapi benda yang sama. Yang VX ni guna yang lain. Soalan I, sekarang ni I pilih AV is equal to dV over dt. So kalau I ambil AV tu is equal to dV over dt, dia akan produce yang mana satu? Adakah dia akan produce VT ataupun dia akan produce VX?
VT.
Kenapa VT?
Sekejap madam.
Nur Yuni Afika.
Ni saya madam.
Do I need to repeat my statement?
Dia akan produce dV over dt.
Dia akan produce dV over dt.
Maksudnya dia macam in sana.
You all kata tadi you all semua faham apa yang I ajar. Sekarang ni I tanya, kalau I ada A as a function of V dan I relatekan dengan kinematic relationship dV over dt, I boleh derive function apa? I boleh derive VT ke, XT ke, I boleh derive VX.
Dia akan produce VX madam.
VX?
Sekejap.
Ini isu dia kalau kelas online sebenarnya. Okay, bila I tanya ada soalan, semua kata faham. Okay, siapa yang boleh jawab ni?
Produce VT.
You akan produce VT. Okay, proof dia yang mana yang ni? Inilah result dia. Tapi sekarang ni daripada soalan ni dia nak apa? Dia nak VT ke dia nak VX?
Dia nak VX.
Dia nak VX, so betul ke yang ni? Ini tak betul sebab dia akan produce V as a function of T. Okay, how about this one? Kenapa C ni salah? Kenapa C ni salah? Satu je kesilapan dia. Apa kesilapan dia kat situ? Raja Ilhan.
Salah dia sebab limit dia.
Limit dia? Kenapa dengan limit dia? Sepatutnya limit dia berapa?
Sepatutnya T daripada kosong ke T.
Kosong ke T?
Apa
Yang satu yang cakap ni?
limit dekat A
Okay, sepatutnya apa?
daripada time kosong ke T.
Kita tak ada time kat sini. Ni dia pakai DX.
Kinematic function dia madam.
Ha?
Kinematic function dia sepatutnya V dV over dx.
Okay, sepatutnya dia V dV over dx, correct. Okay, I tahu. Betul. Terima kasih. Persoalannya sekarang, kenapa C ni salah?
Sebab dia AX bukan AV.
Yes, sebab soalan dia A tu diberi as a function of V, tapi A ni dalam sebutan X. So salah lah. Kan? Ni out of the problem. Okay, yang ni pula. Kenapa salah? Yang ni pun sama tadi. Apa kesilapan dia sebenarnya? Ini sepatutnya bukan AT. Dia kena AV. So jawapan dia sepatutnya sama ada B ataupun D. A dan C salah sebabnya A function tu tak ada kaitan dengan problem ni. Problem ni A tu dalam sebutan V. Yang ni A dinyatakan dalam sebutan T. So salah lah. Yang ni kena bersalah. A is a function of X. Again, kita A is a function of V. Nampak tak V kat sini? So kat sini kita ada A is a function of V. Okay, fine. Kita ada A is a function of V. Fine. Okay, apa? Kenapa D tu salah? Sebab yang ini kita nak cari in term of distance. Tapi yang ni kita dapat in term of time. Okay. So, untuk dapatkan in term of position or distance, kita kena melibatkan dx. Walaupun kat sini ada dx, tapi function dia salah. A dia is a function of x. Kita punya function adalah A is a function of V. Okay, let's prove this one. Okay. Kita ada A is a function of V. A is given to 3 minus 0.1 V squared. Bermaksud A2 is a function of V. So kita nak dapatkan Vx. Bila kita dapatkan Vx, kinematic relationship yang you kena guna untuk derive Vx adalah V dV over dx. V dV over dx. Okay. So bila kita dah keluarkan dia punya kinematic relationship yang terlibat, sekarang ni kita kena rearrangekan dia supaya kita boleh buat integrations. Nak rearrangekan dia macam mana? Kita kena susun mengikut variable. Ini A is a function variable V. Ini variable X. Ini bawa ke sebelah A, dx bawa ke sebelah. Kita exchange the position. So kita akan ada dx equal to V dV over AV. Sama tak? Okay, sama. Alright. So from here then we introduce the integrations in order to produce velocity functions in terms of x. Okay. Alright. Next. Ada soalan? Do you have any question? No? Okay. Thank you. Alright, now for the concept question. Alright, so dia kata apa? Ni concept question. When will the bowling ball start slowing down? Okay, when will the bowling ball start slowing down? Okay, so dia kata apa? Ini statement yang tadi. A bowling ball is dropped from a boat so that is blah 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 blah, assuming the boat experiences a downward accelerations of this. When in the water, determine the velocity when it strike the bottom of the lake. Okay. Tapi soalan dia kata apa? When will the bowling ball start slowing down? Okay. So jawapannya begini. Dia kata apa? The velocity would have to be high enough for the 0.1 V2 term to be bigger than 0.1 V square bigger than 3. Okay. Maksudnya kalau dia less than 3, dia akan start to slowing down. How can we got this? This is, we will get the maximum velocity when A is equal to 0. So we make it this one equal to 0. Then you will get these functions. Okay. So maksudnya bila enough high value of the velocity. Okay. Tapi bila dia less, dia dah start slowing down the velocity. Okay. So basically, in order to answer for this kind of concept question, we need to relate with the basic concept thing. Contohnya yang inilah. Alright. So balik, you can try to understand about the statement here. Okay. We have not much time right now because I need to finish everything by today. Okay. Next is about the group. Other group problem solving yang mana dia melibatkan again A is a functions of velocity, A is a functions of V. Okay. Apa statement dia? The car starts from rest. The car start from rest. So maksudnya V initial equal to 0. Daripada statement tu dia dah boleh keluarkan apa information yang dia ada sebenarnya. Okay. the car start from rest, so meaning that the initial velocity is equal to 0 and accelerate according to the relationship A is equal to this. So daripada function ni you dah nampak dah ada variable V, bermaksud A ni is a function track that has a radius of 200 meters. Okay, dia kata circular track. Lukislah circular track. Radius berapa? 200 meter. Okay, dia travel dalam circular track ni. Okay, calculate the velocity of the car. Calculate the velocity of the car after it has traveled halfway around the track. Okay, calculate the velocity of the car after it has traveled halfway around the track. Okay, so bermaksud you punya velocity ni kena dapatkan nilai dia berdasarkan distance x. Berapa distance x kat sini? Okay, dia nak dapatkan berapa V apabila x equal to halfway of the track. Okay, berapa halfway of the track ni, macam mana kita nak kira? How can we calculate halfway of the track? Macam mana formula untuk dapatkan lilitan bulatan ni? Apa formula?
Pi R.
2 pi r.
Ha?
2 pi r.
2 pi r. Itu kalau complete one circular kan? Kalau halfway bahagi 2. So maksudnya x unit is equal to pi r. Okay. Can you see here? Your life is not so easy, right? Okay. So everything is given not direct. Okay. There's something that you have to think about what is the value of the x in here. Okay. What is the function that related to use for this problem? Okay. Alright. So first thing first, based on the question here, dia ada dua benda yang you kena tahu. Satu, V is a function of x. And then second one, you kena tahu what is x value here, which is equal to halfway around the track. Okay, we are given radius, then you can calculate the total distance. Alright, so next is what is the maximum car possible speed? Okay, what is the car's maximum possible speed? Berapa speed V maximum? So V maximum berlaku waktu bila? When A is equal to 0. Okay. Alright, so now first of all, before we know that x here is equal to pi r, but we need to have the function first. We are not given the velocity function. Then we have to start with derive the velocity functions. Okay, so we are given this. Alright, we are given this function directly in the statement. This one is not given directly, but they are given in word, in a sentence. Okay, then we are given directly also in the sentence. Alright, and then you need to define V after half lap and you have to determine the maximum speed. Alright, so first of all, as I said, before we can answer for this, you need to get the function of V first. V is a function of what? V is a function of X. Kenapa V is a function of X? Sebab yang dia nak after half lap. So yang mana lap ni boleh di-describe in term of distance. That's why you punya velocity function ni dalam sebutan x. So we are given A as a function of V. So now you have to think about what is the kinematic relationship that need to be used for AV ni untuk menghasilkan V as a function of x. Okay. So we know that, okay, dah banyak kali cakap bila sebut V as a function of x by given AV, the kinematic relationship adalah V dV over dx. I repeat again, untuk A function of V ni dia ada dua possibility. Sama ada you guna dV over dt or you are using V dV over dx. Yang ini boleh menghasilkan Vt dan later on xt. Yang ni hanya boleh menghasilkan Vx sahaja. Okay. Right, so from here, then what? Kita bawa AV ke sebelah, dx ke sebelah, then you have this. Okay. Alright, and then we put the limitation x naught to x, v naught to v. So x naught kita akan equal to 0, x kita adalah equal to ni, pi r, half lap. Okay. And then v naught kita is equal to 0, and then what is v? Okay. Alright, so once we have this, then you complete this problem, these integrations. okay, where you have this detailed value. Okay, as I said tadi, x0 is equal to 0, b0 also equal to 0 sebab dia start from rest. Okay, and then x is equal to what? X is equal to pi r, which is we got this one. And v, ini yang kita nak cari berapa. Okay. Right, so you solve for these integrations, then finally you get this result. Okay. So this is the result for the from these integrations. Okay. So what should we do now? Okay, we just get the result value je lah. Okay, yang ni selepas dia dah ganti masuk semua nilai x ni sebabnya you boleh letak x sahaja dulu. You boleh je letak dalam sebutan x. Boleh je, tak ada masalah. Okay, and then later on you kena substitute x lah. Okay, alright, so for this case dia dah siap-siap masukkan nilai x dalam dia punya integrations tu. Okay, so finally this is the result for final value of v. Okay, yang mana you just rearrange kan yang ini bawa ke sebelah jadi bahagi. Okay, kan ada this one tambah dulu tolak 3. Okay, nak mudah, what can we do? We bring 3 minus exponent blah blah blah. Okay, equal to 0.001v square. Okay, and then v square is equal to 3 minus exponent over dengan 0.001. Because we want to get the velocity, hilangkan square ni dan square root. Then we get this final velocity. Okay, so this is the result. The result of the velocity after dia travel half lap. Okay, on the route tu. Okay, and then dia kata apa? Determine the maximum. The maximum speed the car can reach. Okay, the maximum speed berlaku apabila acceleration is 0. So based on the given a function just now, we make it the equal to 0. Okay, so then you can get what is the maximum speed. Okay, so you will have v is equal to this one lah. Okay, to check whether your answer is correct or not for this, you have to compare with the calculated value before. Kalau yang ini less than what you have this one, okay, bermaksud you punya yang ini yang salah. Okay, maksudnya ada masalah dengan calculation yang sebelum tu. Vmax maksudnya dia mesti sentiasa greater than whatever you have calculate before lah. Alright. Okay. Do you have any questions so far? Ada soalan?
Yeah.
Okay. So this is the summary of kinematic relation based on the rectilinear motions. Okay. So basically kita dah selesai lah. Okay. On the basic concept of the rectilinear motions. On the kinematic relations. Okay, so there are two ways of the solutions. Either you need to differentiate or integrate. Okay, you have to differentiate position to get velocity, and then you have to differentiate velocity to get accelerations. Okay, to dapat velocity, integrate position. Untuk dapatkan acceleration, integrate velocity. Sama ada dv over dt or v dv over ds, because a ni can be a as a function of t, a can be as a function of x, a can be function of v. Yang ni directly guna dv over dt, yang ni guna v dv over dx, tapi yang ini dia ada pilihan sama ada dv over dt or v dv over dx. And then if you are given first accelerations, you integrate acceleration for velocity, and then you integrate velocity for the positions. Okay ni. Dah dapatkan velocity, kita integrate accelerations. Okay, bila kita dapatkan position, kita integrate velocity. Then we will get the position functions and the velocity functions. Okay. Alright, and then as mentioned before, in the limitations, okay, we keep mentioning about S0, V0, initial position, initial velocity. So ini berlaku apabila particle is at t equal to 0. Okay. Alright, and then this is what we use when we are talking about variable A. Maksudnya A itu adalah bentuk function. A is a function of t, A is a function of x, and A function of v yang ini. Okay. when you define that in your problem bukan melibatkan function A, maksudnya diberi satu value sahaja, okay, bila dia kata satu value tak ada function, satu value contohnya 7 meter per second square, okay, ini yang dikatakan sebagai constant acceleration, any value lah, maksudnya dia tak ada function. Function tu maksudnya apa? A is equal to 2t plus 3t square, ini dinamakan function. Maksudnya A tu berubah-ubah mengikut kepada T. Yang ni A tu constant, at any time A tu masih A yang sama. Okay. Kalau A you based on these functions, the way to get the velocity and the position should follow this procedure. Okay. Should follow this procedure. And what if your A is constant? If your A is constant, okay, tak payah pening-pening kepala, tak payah nak buat apa-apa integration yang macam ni, kita boleh guna kinematic equations. Okay, kita boleh guna kinematic equation. Dia ada 3 kinematic equations. Okay, ini adalah equation yang kita boleh guna pakai untuk dapatkan velocity and positions apabila A is constant. When A is constant. Okay, dia kata the 3 kinematic equation can be integrated for the spatial case when A constant to obtain very useful equations. A common example of constant is acceleration is gravity. This is a common example for the constant acceleration macam example yang kedua tadi. Okay, yang mana bila dia baling bola, dia free to fall. So maksudnya dia melibatkan gravity. Yang mana gravity ni kita consider sebagai constant accelerations. Okay, yang mana the condition Earth. Okay, so the value is 9.81 meter per second downward. So you can freely use these 3 equations to solve kalau dapatkan velocity dalam sebutan T. Ini velocity dalam sebutan positions. So ini adalah position dalam sebutan T. Okay, so we will see example after this. Okay, maybe tomorrow about how can we implement these 3 kinematic equations. Alright. Okay, before we end our session, kita akan tengok on this problem lah. So we don't have enough time to discuss about this by using these 3 equations. Okay. Right now, I give you 1 minute. 1 minute to answer for this question. So once you answer for this question, then we can end our sessions today. Read. Okay, in dynamics, a particle is assumed to have what? A, B, C, or D? Particle, they translate all
A.
and rotate ke?
Yes.
Tidak. Jawapan A tu salah. Kenapa ramai jawab A? Tadi kelas tadi pun sama juga. Tadi awal-awal tadi ada cerita dah. Particle dia hanya apa? Translate saja. Yang mana bila translation dia hanya only a mass sahaja. Bila only a mass, kita akan hanya tengok based on the translations only. Dia tak ada rotation. Dia kata a mass but the size and shape cannot be neglected. Tak boleh. Ini hanya untuk rigid body sahaja. No mass or size or shape maksudnya it just point. So tak boleh nak kira apa-apa motion. Okay. So jawapan dia adalah B. Ni, the average speed is defined as what? A, B, C, or D. Ini nak kira apa? Ni nak kira apa ni? Ni average velocity. Ini average speed. So jawapannya apa? C. Okay. Alright, so with that, thank you very much for today. Okay, so tomorrow we will continue to the group problem solving 3. Okay, yang mana kita akan tengok how can we implement these 3 kinematic equations. Alright, so thank you very much. See you tomorrow. Tomorrow ke hari Khamis? Hari Khamis.
Thank you.